Hi, my name is Charity Majors. I am really happy to be here. Only 50% of which is due to the awesomeness of the ChefConf speakers room. I don't know if you guys knew this, but they have expensive chocolates, bacon, bacon donuts, chocolate dipped bacon, and bourbon and scotch. So you should really submit next year. My talk today is called There and Back Again, a chef tale. Or alternately, how we drank the Kool-Aid, sobered up, and learned to cook responsibly. I really apologize that I don't have Kool-Aid Jell-O shots for you guys. This is really a serious failing on my part, and I really deeply apologize. But this talk is kind of like a love story, right? Like, you find a tool, you fall in love with it, you think it's perfect, it's totally going to solve all your problems and not create any new ones. Well, you know how love stories turn out. You get to know each other better. One of you probably snores, one of you is kind of a slob, and you find out that your perfect tool is really amazing at some things and pretty bad at some other things. And also, you were kind of young and dumb back then, so you made some poor life choices. So in that context, I'm going to talk about our journey with Chef at Parse over the last 3 years. The things that we've learned to love and the things that we had put into Chef and ended up taking out again. And by the way, there is no judgment in this room, right? What's good, I'm going to talk a lot, I'm very opinionated and I like to rant about what's good and what's bad, but I'm talking about what's good and what's bad for us. Like the things that we've tried that really didn't work for us. And if I say that something really sucked for us, it doesn't mean that I think you're stupid if it actually works really well for you, right? There are hard engineering trade-offs that need to be made for everyone. So, for those of you who don't know much about what we do, Parse is a backend for mobile developers. We provide core data, analytics, push, background jobs, server-side JavaScript, SDKs, basically everything you need to build a really rich mobile app without ever having to touch your backend, which for mobile developers is like the holy grail. We currently host over 500,000 apps, and my team, a couple of whom are here, we basically do all of the backend infrastructure, operations, DBA, reliability work for all that 500,000 apps. A couple of basic facts about our stack. We run in AWS. We have on the order of thousands of nodes. Last year, we migrated from EC2 Classic to VPC. We are heavy users of MongoDB. We actually have one of the world's largest and most complicated MongoDB ecosystems. And we're also fairly robust users of Cassandra, Redis, and MySQL. We do a lot of databases at scale. Our original stack was Ruby on Rails. And over the past year and a half, we have been rewriting components compulsively in Go, because guess what? Rails doesn't scale. So this is our mission. These are our challenges as an org. Number one, solve mobile apps for the universe. Not one by one, but thousands by thousands and tens of thousands by tens of thousands. Basically, anytime we have to think about an individual app, we've failed in some way. Much like when you're managing servers at scale, anytime you have to log into a server or think of an individual node, you've failed in some way. It doesn't mean it's terrible. It happens from time to time. But you have to closely manage the amount of attention that you're paying to any individual app or any individual node. We need to ship products really fast. The mobile ecosystem is growing and vibrant and insanely changing from moment to moment. And we need to support relentless growth. Now, when I say relentless growth, I mean graphs like this, just for the last year. This is our active monthly Parse installations. It's doubled again since the holidays. And this is our API requests per second, which have also doubled again since the holidays. Basically, over the past 3 years, we have effectively built and rebuilt our infrastructure 3 times because our growth 10x'd 3 times. So why do you actually care about our mission? This might not seem too relevant to you? Well, you care because our mission informs our priorities, right? And the engineering trade-offs that we have to make. Infrastructure is only interesting to us insofar as it helps us achieve these key goals. We're still a startup. Like, we have a very limited number of engineering cycles, and we don't spend them on beautiful feats of engineering just for the sake of it. We optimize our engineering hours and processes to achieve these goals. And our mission is not your mission. So everything that I say will only be somewhat applicable to you, right? This is also not a redemption story that ends up with us having arrived at the perfect software engineering model of Chef deployment, like a flawless continuous delivery pipeline. Like, that's what you get when you listen to Phil Dibowitz's talks about Facebook. Because that's their mission, right? That's not our story. This is a startup story. It's a best effort story. Like, I make no apologies for that. We have built a system that allows us to achieve our goals and almost never causes outages. So, I'm going to go back to the very beginning and talk about our earliest days with Chef. I joined Parse as the first infrastructure hire in April of 2012. I had never used Chef, and it was love at first sight. I had used almost everything but Chef. I had used Puppet, CF Engine, System Imager, Pixie, Kickstart, Fabric, and I basically loathed them more or less equally. It's like configuration management was totally a necessary evil until I started using Chef. I'm not gonna lie though, the learning curve was pretty steep. 3 years ago, all right, how many of you started using Chef like more than 2.5 years ago? Yeah, so you learned almost everything from reading the source code, right? How many of you started using Chef in like the last year and a half? I fucking hate you. I am so jealous of you. When I was your age, I had to write recipes with a pencil. Anyway, I made a ton of mistakes, but I loved how much sense it made. I really loved the robustness of the community cookbooks and the friendliness and openness of the culture and how responsive the chef team was in IRC and how they never told me I was being stupid. So I love Chef. And I went a little crazy. And I chefed everything. Like, starting with the base systems, like reverse engineering all the one-offs that our software engineers had built, setting up bootstrapping, packages and configs, DNS and host names, writing my own cookbooks. Around this time, I convinced my friend Ben to join me, and we dived into service registration, discovery, and auto-generating configs from roles. When I joined Parse, literally the source of truth, this is such a software engineering thing to do, the source of truth for how services talk to other services was a list of EC2 IP addresses checked into Git. So we made roles, right, for types of hosts. And we generated these YAML config files from Chef. We used the same roles to generate monitoring. We're like, this is amazing. This is the best thing ever. What else can we do with it? Databases. We have tons of databases, especially Mongo. So we built all of this really fancy stuff for managing and automating Mongo replica sets. I actually wrote a library for AWS that would let you provision and raid EBS volumes and do automatic snapshotting and restoring, provisioning new replica sets from Chef roles. I wrote a Cassandra cookbook that would handle assigning initial tokens to nodes. We gingerly backported the community MySQL and Redis cookbooks onto what we had. And we're so on a roll at this point. Every time we have a technical problem, we would ask ourselves, well, how do we do this? And the answer that we would give ourselves was Chef. How do we do this with Chef? We even got to the point where we're like, well, we hate Capistrano. Deploys really suck. Let's see if we can do that with Chef. This is about the time that we started to sober up. We're like, this is not actually making things better. This is what I would call our era of peak Chef. We started to encounter some really annoying things, and it started to feel like we were spending more time fighting our Chef infra than building our actual infra. I love that GIF. We would have like database primaries restarting when we weren't expecting them to because of some config file shifting due to some nested dependency. Or like we needed to coordinate changes across, tens or hundreds of nodes in some semi-ordered way. Or like two people would be uploading a cookbook at the same time and clobber each other's changes. Or we'd have to just run Chef everywhere and restart all the services just to get another node into service. So obviously, we were doing some stupid things. This was great, right? Because it forced us to actually sit down and think carefully about each one of our pain points and ask ourselves, is this painful because we're doing something wrong with Chef or wrong with our Chef workflow? Or is Chef actually the wrong tool for us to use to solve this problem? Well, there were plenty of both. The tooling and support weren't quite there, but we had also done some things pretty shoddily. But there were things that it was just fundamentally the wrong tool for. And we're going to talk about both of those. But first, let's talk about some of the many embarrassing mistakes that we made. I mean, some of the things that we just did really badly with Chef. Some of the straight-up mistakes that we made with Chef for one reason or another. When we were first starting out, I'm like, roles are amazing. I'm just going to put everything in the roles because I can search on it. Great plan. No. Bad plan. We also weren't clear on the distinction between a role and a service. So we ended up creating way too many roles to distinguish just between instantiations of a certain service, like one role per database replica set. That just got unmanageable. We also realized around the same time as most of the rest of the Chef world that roles have problems for like the same reasons that databags have problems. It's really hard to test cookbooks that rely on a lot of roles or databags or search commands. And you can't version your changes. We ended up investing a lot of work after that to migrate from roles that contain all the recipes to having just roles that are a single top-level wrapper recipe with all the attributes it includes. Our first round of cookbooks also had a bunch of definitions, because that's what we saw other people doing, but those are bad because you can't inherit them across cookbooks, so we ended up rewriting a lot of those. And using knife search is slow. Like, it's just really, really slow with lots of nodes. And unless you're just looking for seed nodes, it's also not the most up-to-date information, especially if you don't have a way of automatically reaping old nodes and deleting the Chef node and client keys in more or less real time. I have more mistakes. Mistake slide 2. The first one is entirely my fault. I just started forking community cookbooks and modifying them. And there was a little voice in the back of my mind that was telling me, this is a bad idea, you're really going to regret this, you're really going to be kicking yourself about this. But I'm like, move fast and break things. Most startups fail, and it's usually not because they didn't do their Chef correctly on the first try. One of the great things about Chef is that there are so many great community cookbooks. One of the worst things about Chef is that so many of those community cookbooks were developed by shops with really intricate interdependencies that you don't share. Like the Heavy Water or the InfoChimps, like cookbook communities, where if you want to import one cookbook, you also have to install Silverware and Blue Pill and Boost and CouchDB and God knows what else. We didn't build a super solid staging environment. To this day, we still rely on canarying to some extent. And then there's the irritating fact that it's still not trivial to have a single source of truth unless you have a fully functioning continuous deployment pipeline. It's really too easy to have multiple sources of truth for data that should really only have one source. Now, getting the staging environments and CD, CI pipelines are not the hardest thing in the world to do, but we haven't done it yet. I mean, these are all really solvable problems, right? Some of them are painful, some of them are annoying, some of them are pretty easy, some of them we have solved. We got a lot better at Chef the first year or two. But part of getting better at Chef was learning when not to use it. Sometimes it's just not actually what you want, or it needs a little bit of help. These are basically the problem categories that we experienced as we grew from being a super tiny startup that may or may not ever ship anything to being a mid-sized startup with thousands of instances and half dozen engineers or so. Bootstrapping from scratch, service registration and discovery, managing software, internal software in particular, and databases. Let's start with bootstrapping. How do you get from a vanilla Ubuntu AMI to putting that node into production? I started out by launching every single node with Knife EC2 from a vanilla Ubuntu image, because I'm like, this is the only way that I can be perfectly sure that all of my cookbooks actually work. Well, that was retarded. That was dumb. I mean, first of all, it takes a really long time, right? Like 30 minutes, an hour maybe. And what percentage of the time does something flake out and fail? Like 90%, maybe 10%, but it feels like 90%. And it always happens at the worst possible time. Also, just launching instances via Knife EC2 in general got really annoying really fast as we grew. We had all of these really terrible shell wrapper scripts that would help us bring up like 100 nodes of this type, evenly balanced across availability zones by auto-incrementing the host names and like not using existing host names. It's got really bad really, really fast. So how do we solve it? First of all, obviously, you bake most of the work into the AMI with Chef. Like you Chef to build your AMI, and then you auto-scale in groups to scale it, to launch instances. Now, the way this works for us is we have a bootstrap script in our base AMI that infers what the role type is from the name of the auto-scaling group. It registers itself with the Chef server using that role name, assigning itself a host name from Zookeeper, which is auto-incrementing. Then it runs Chef client, figures out which version of the software it needs to be running, downloads that bundle from S3, unpacks it, starts the service up, registers itself as an alive node with Zookeeper, and then deletes the bootstrap script. So if it reboots, it won't do that again. Now all we have to do is just adjust the size of the ASG, either by hand or by pegging it to some key metric. And we now have like 50 auto-scaling groups, so we wrote some automation on top of the automation for auto-scaling groups to automatically manage versioning and updating the AMIs. And you're also, if you're relying on auto-scaling groups, you're really going to want to write a cleaner that will delete all of your nodes that have gone away. So, provisioning solved. The next problem was service discovery. Now, it may shock you to hear this. Chef is not actually the best solution for real-time service registration and discovery. It's just not built to serve real-time data, right? Real-time search needs real-time data. And there is software out there that is built to do this. Now, like I said before, when I started at Parse, our service registration and discovery was IP addresses that were checked into GET. And we made this a lot better by turning that into roles and generating those YAML files by running Chef, right? That was a lot better. Let's be clear. This was not like a terrible solution. It was a solution that bought us like a year and a half of working totally well enough. And we could have kicked this can down the road even farther by investing more work into our Chef process so that we could run it every few minutes. It was faster, more reliable, blah, blah, blah. But we looked at where we wanted to be eventually, and it was not running Chef every 30 minutes to get an updated list of nodes. We decided to invest the energy into making an actual real-time service registration and discovery solution, because that's the right tool for the job. We use Zookeeper. I have a lot of feelings about Zookeeper. Zookeeper the server, great, rock solid, battle tested by Netflix, everyone out there on the internet. The problem, of course, is that half of the intelligence for Zookeeper is in the client. So your experience with Zookeeper will depend heavily on which client you're using. And there is effectively no good client out there for anything but Java and arguably Python, which are not the languages that we use. So what we do is we run a little local, lightweight Zookeeper agent on each node that reports real-time statistics to Zookeeper about the service and the node itself. If you have a slightly higher tolerance for risk, I think you should use etcd or Consul. And let me know how it goes. I really do believe that Consul is like the future of service discovery. I'm waiting till 1.0. For things like Node.js, where we used a lot of knife searches, and where it would literally take almost an hour to run Chef client, we replaced those Chef searches with a Zookeeper search function, which is faster, and it cut down the length of time and also made it more accurate. I also want to briefly talk about cron jobs, and it may seem odd to talk about cron jobs in the context of service discovery, but this is a really classic example of Snowflake hosts and how to avoid them, right? Like when you're a baby startup and you're just trying to ship a lot of things fast, you aren't trying to build giant distributed systems for everything, you aren't doing an auto-scaling group to get a single host out there so it'll automatically rebuild itself. It's just kind of a pain in the ass. It'll take you 2 hours instead of 5 minutes. Sometimes you just need one host to do something or one cleanup job to run once a day. It's really tempting to use Snowflake hosts. But a better solution is to deploy it to a whole class of hosts and then use distributed locking to make sure that it only runs once, right? Run the cron job in all the hosts, but only one gets a Zookeeper lock, and the rest will just quietly bail. All right, that's about it for service discovery. Now let's talk about managing configs. And this can get confusing because terms like software and configs are about as vague as it gets. So let's be really explicit about what we're actually talking about here. There are 3 types of software and config files that we're going to talk about. There's system software, there are developer services, and the kind of catch-all bucket that I'm going to call internal software or operation software. And let's start with system software. Use Chef. Chef everything. Like seriously, this is what Chef is so good at. There is nothing better at this than Chef. Like, manage your debs, your RPMs, like your system software, your dependencies, everything that you build that base image out of. There's nothing better than Chef. And then there are your developer-owned services. Like for us, it's like our API server, Cloud Code. We have like 20 or 30 of these services that we support on the back end. First of all, your developers own these, right? Developers should always be deploying their own code, owning their own services, deploying their own configs, and bundling those together. At one terrible moment in Parse's past, we were managing software configs with Chef, but doing deploys for the software that used the configs, using our own, like Capistrano for Ruby and our command line tools for Go. This was terrible, right? Like, you had to coordinate a Chef run to change a config, and then a software deploy to pick up the changes. And for some point of time in there, those two might be inconsistent, and if something happened to restart, it might not start back up. And if you had to roll back, you had to roll back both Chef and the deploy. Like that, terrible. No, your config changes are software changes, so you need to bundle them together and version them together and deploy them the exact same way as your software changes. You need to be able to roll them forward and back in a single action. And one really good reason not to deploy your software using Chef, you want it to have as few dependencies as possible. You want it to be as fast as possible and not to fail because some remote apt repository is like mistakenly like down or something. It's just not a necessary dependency. You don't want every deploy to depend on all the cookbook changes and state validations, because that is not the smallest set of necessary changes. If you do actually need to gate a code deploy on some system change, like say you can't deploy this new version of some software until ImageMagick is upgraded, put that in your start script as a dependency, or make it fail fast and automatically roll back. Our average chef run is still about 20 minutes. I was really sad to miss the session on speeding up chef runs. I hope someone on my team hit that. Well, I'll catch it online. But like for us to deploy any of our backend Go services, it's under 2 minutes. That's like an order of magnitude when it comes to fixing shit that you just rolled out that was bad. Lastly, and most nebulously, I want to talk about some best practices for what you can kind of loosely categorize as ops software. Now, this is harder to reason about because it could be anything from 10 lines of bash to a really sophisticated piece of software engineering, like tens of thousands of lines of Go code with full test coverage for doing like automated tenancy management for all of your databases. If you're like us or most shops, you probably have tons of examples of both of these and everything in between. And like lots of people, we started out by just putting scripts into Chef as file resources or templates. This gets messy really, really fast. You add a script to one type of host, then you need to add it to another type of host, then you end up abstracting it out into its own cookbook, and you're checking in libraries. It's just, Chef is the wrong way to bundle software. You should be using Chef to manage your bundled software. For the ops software that you have that is like software engineering, treat it like first-class software engineering. Like, make a Jenkins job, add test coverage, bundle it and deploy it the same way you do all of your other software. And for the quick and dirty stuff, like the smaller scripts, I really like just having a wrapper script that bundles them into a deb or an RPM, versions it, uploads it to your repository, and then you can manage the version number with Chef. So that's about it for software and configs. And the last thing I want to talk about is managing databases with Chef. And especially databases at scale. This is a very personal topic for me. 2 years ago at ChefConf, I gave a talk called Managing MongoDB Replicate Sets with Chef. Did anyone see that? All right, I want to take back everything I said. Maybe retract is slightly too strong of a word, but I gave a lot of advice for things that worked really well for us when we had 2 to 5 Mongo replica sets, and completely fell apart when we had an order of a magnitude more. And this isn't just Mongo specific. We started running into similar problems with all of our databases as we multiplied in scale. Basically, the more you need to do DBA work, the more you need to move things around and make changes to your database ecosystem, the more you're going to need to take your tooling and your automation outside of Chef. Chef is really good at establishing a base system or resolving your system to a desired state. Chef is really not designed for issuing imperative commands across dozens of database clusters and hundreds or thousands of nodes that all need to have some understanding of ordering or sequencing or an awareness of each other's health or each other's state. Chef is also not good for doing automatic remediation when problems are detected. Some operations should only ever be either intentional or happen automatically as a means of DR, right? Like, upgrading and restarting databases is part of a Chef run. Have you ever wanted Chef to do this for you? I haven't. I have certainly had Chef upgrade and restart my databases, but I've never wanted it to. Or flipping primaries, right? Flipping your MySQL primary, flipping your Redis primary. Maybe this happens automatically because your tooling is amazing and it automatically detected a problem and like flipped everything. Maybe this happens imperatively because you told it to. But do you ever want this to happen as a result of a Chef run? No. Chef should not dictate your database config if you're running at scale. You should infer it when Chef runs and not set it when Chef runs. This is just I don't even know if it's worth reading all this slide, but just a common list of DBA operations that we have to perform. And what do all these things have in common? Like, they're all either imperative commands or they're problem remediation. They're not state resolution. You don't want to kick off a rolling upgrade for 300 Mongo nodes and have it, upgrade 3 out of 5 on a replica set at the same time, right? You want to do one at a time on each replica set and not let each replica set proceed until that node has come back up. But, not everybody who runs databases needs to do a ton of DBA work. And if you don't have a ton of DB ops to do, it's perfectly reasonable to manage and configure your MySQL instance or your Redis instance or your replica set with Chef. Because when you're a small shop, you've got better things to do, right? It's perfectly fine to log into a database node and perform an action. Whereas when you're running at scale, you should never have to log into a database node to perform an action. If you have to log into a node, you have failed in some way. You should have tooling to do that for you, and you should be able to version your running states. But just as importantly, these things that I'm telling you about how this stopped working for us as we grew larger, it's just as important not to over-engineer or over-instrument in advance of your actual needs, right? This worked really well for us for a really long time. It took us years to outgrow our Chef-managed database systems. And it took us many engineering months to develop the DBA tooling that we needed to manage them correctly. The Chef stuff that I initially built out met our needs for a long time and took us a long way. So this is definitely not me judging you if you're saying you use databases with Chef and it works great. It's me saying in a couple of years, it might not. Basically, pay attention to your actual needs, the actual mission, the things that are actually hurting your developers and taking their time away from the things that they want to be building, and put your time into solving those problems. The place we're in now is we configure the base systems with Chef. Chef infers any changes to the running replica set configs and publishes it up to the Chef server so that monitoring will generate the correct checks for each node. We also have a lightweight agent that runs in each database host and publishes facts about the running state to Zookeeper, since that's the primary source of truth for our production. But for performing DBA tasks like upgrading the fleet, changing configs, et cetera, we use our external tooling, which generates a JSON config of the current state, which we can then check into Git and version. For Cassandra, we use Preem by Netflix. It's amazing. You can just shoot a node in the head. It'll bring another one up in the autoscaling group, pull in all of the data it needs from nearby nodes in the ring or from the S3 backups. It does automatic backing up to incremental backups to S3. It's like magic, dude. It's so cool. For MySQL, we use some homebrewed scripts. We send all MySQL connections through HAProxy, and we manage the master by setting a flag in Zookeeper. And all we have to do is set the flag. Pat wrote this, and it repoints the old master to the new master. It's pretty sweet. But again, not something that you would want to have run as part of Chef Run. So we're pretty happy with this. It's a hybrid system. Database state is managed with external tooling. And Chef helps us keep our monitoring all up to date without ever having to take any manual actions. So we're basically at the end of the talk here. I want to just wrap up by summarizing what we love about Chef, what we still suck at, and what we've decided not to use Chef for. These are all the things that we still heavily rely on Chef for, the things that we love using Chef for, and we have no plans to change. Basically, it comes down to building and configuring base systems, bootstrapping AMIs from scratch. We love it for getting us from vanilla Ubuntu to the base system that we rely on. It's programmatic, it makes system upgrades smoother, it's amazing. Chef is not our source of truth about the running system, though. Chef is what configures the system to report their characteristics to Zookeeper. Things we still suck at. Robust testing environments, a single push-button workflow to publish to both Git and the Chef server, running Chef continuously. Honestly, it hasn't been key to our mission to fix these things yet. We know basically what's required, and when it becomes a significant source of pain, or when it starts causing outages or system-impacting events, we'll fix these problems. But we don't change our cookbooks very often because our dynamic data lives elsewhere. And there's also like the additional fact that like we were planning on moving to Facebook, off of AWS into Facebook for the past 6 to 9 months, and so we were like, well, we're not going to invest a shit ton of time into fixing the old system if we're going to be moving on to the new system. Well, that's no longer on the table, so now we're back at ChefConf and looking for ways to really fix up our old systems. And these are the things that we still, like, we put these in Chef at one point, but we now believe they're better served by different solutions, like real-time data, internal software development and deployment, and any type of database management at scale. For all of these things, Chef will get you up and running really fast, and that is not a bad thing. That is a good thing. It'll take you a long way as a startup if you have like 1 or 2 people. Just be aware that as you grow as a company, you may need different solutions for these problems. It's always about the mission, right? And just like ruthlessly prioritizing what to spend your limited engineering resources on. And your calculation has to be based on your appetite for risk, your stage of growth, and the engineering resources that are available to you. And nobody else can make those decisions for you. So in summary, Chef many of the things. Chef is an amazing tool. Like I really believe, I've tried almost everything, and I really believe it is the best of breed at what it does. That doesn't mean that it's magical pixie dust that you can just sprinkle onto any part of your infrastructure to make it better. But it is pretty freaking awesome, and my life is definitely better because it exists. So, thank you, chefs.
Thank you, Charity. We have time for probably a couple questions.
Did you ever look at Chef Push for doing some of the real-time stuff?
No, never heard of it. Chef Push? Yeah, no, actually I heard of Push Jobs yesterday. There's a whole, like, I'm not even kidding, like the amount of tooling and stuff that has happened in the last year is amazing. And we are really excited about looking into it. We had kind of mentally detached because we expected to be moving off of open source onto like the closed Facebook ecosystem. And seeing what's been done in the last year is really exciting. It's definitely one of the things that we're going to be looking at. It seems like there is a lot of energy going on around orchestration stuff too, which I'm looking forward. I don't think it's going to replace what we're doing, but I at least want to see like how it measures up.
All right. Well, thank you.
Thanks.